GIS, Gas Insulated Substation, and AIS, Air Insulated Substation, are two fundamentally different approaches to electrical substation design, each with distinct advantages and applications in power transmission and distribution systems. AIS is the traditional substation design where air serves as the primary insulating medium between live parts and ground. Busbars, bare conductors supported by insulators, circuit breakers, bulk oil, minimum oil, SF6 or vacuum types, disconnectors, isolators, mechanical switching devices, current transformers for measurement and protection, potential transformers for voltage measurement, surge arresters for overvoltage protection, support structures, steel or concrete structures. 1. Lower initial cost for small to medium capacity substations. 2. Easier maintenance with visible components. 3. Simpler expansion capabilities. 4. Better heat dissipation due to open-air design. 5. Proven technology with extensive operational experience. Air Insulated Substations, or AIS, come with several disadvantages. First, they have a large footprint requiring significant land area. They are also more susceptible to environmental factors like pollution, moisture, and animals. This exposure means more frequent maintenance is necessary. Additionally, they tend to have lower reliability in harsh climates. And of course, there are safety concerns with exposed live parts. Air-insulated substations are typically found in outdoor settings, especially in rural areas where space is available. They are used in lower voltage applications, although they can be utilized up to 765 kilovolts. These substations are best suited for areas with moderate environmental conditions. Gas-insulated substations, or GIS, use pressurized sulfur hexafluoride SF6 gas as the primary insulating medium within sealed metal enclosures. Enclosed busbars are housed in SF6-filled tubes. SF6 circuit breakers feature a compact design. Disconnectors and earthing switches come as enclosed units. In some designs you will find gas-insulated transformers. Surge arresters are often integrated. Control cubicles are used for monitoring and operation. And finally, the gas monitoring system keeps an eye on SF6, pressure and quality. The compact size of GIS requires only 10 to 30% of the equivalent AIS footprint. It offers high reliability with protected components. GIS has minimal environmental impact on performance. It also has lower maintenance requirements. Enhanced safety is achieved with enclosed live parts. GIS is suitable for urban and indoor installations. Lastly, it has a longer service life, typically 30 to 40 years. Higher initial cost, though often offset by land savings. SF6 handling requirements, as it is a potent greenhouse gas, more complex maintenance requiring specialized skills, limited expansion flexibility, and higher repair costs for internal faults. Urban areas with space constraints, indoor substations, basements, buildings, harsh environments, whether it's coastal, polluted, or even extreme climates, high voltage applications, typically 72.5 kilovolts and above, special installations like offshore or underground. GIS requires only about 10 to 30% of the space needed for equivalent AIS. AIS may need 5 to 10 times more land area than GIS. GIS requires only about 10 to 30% of the space needed for equivalent AIS. AIS may need 5 to 10 times more land area than GIS. GIS has higher reliability, typically 99.9% versus 99.5% for AIS. AIS is more prone to external faults, animals, pollution, and weather. GIS uses SF6 gas, which is 23,500 times more potent than CO2 as a greenhouse gas. AIS has no F-gas emissions, but has a larger physical footprint. The initial cost of GIS is typically 2 to 4 times more expensive than AIS. However, the life cycle cost of GIS is often more economical when land costs are high. On top of that, the maintenance cost of GIS is generally 30 to 50% lower than AIS. GIS provides better personnel safety with enclosed live parts. AIS, on the other hand, has a higher risk of electrical flashovers. Some modern designs combine GIS and AIS elements. GIS is used for high-voltage components, while AIS is used for lower-voltage connections. This results in mixed technology switchyards. Some modern designs combine GIS and AIS elements. GIS is used for high-voltage components and AIS is utilized for lower-voltage connections. This creates mixed technology switchyards. The future of substations is evolving rapidly. We're seeing the development of environmentally friendly insulating gases as alternatives to SF6. Digital substations are becoming more prevalent with the integration of IoT and SmartGrid technologies. Space optimization continues with even more compact designs. Advanced monitoring techniques like AI-based predictive maintenance are enhancing reliability. And modular solutions such as prefabricated substation units are offering greater flexibility. Choosing between GIS and AIS depends on several factors. These include available space and land costs, environmental conditions, voltage level requirements, reliability needs, budget constraints, future expansion plans, and aesthetic considerations, especially in urban areas. When selecting between GIS and AIS, you need to consider available space and land costs, environmental conditions, voltage level requirements, reliability needs, budget constraints, future expansion plans, and aesthetic considerations, particularly in urban settings. GIS and AIS technologies each serve important roles in modern power systems. GIS offers space savings and reliability advantages, which are particularly valuable in urban and constrained environments. On the other hand, AIS remains a cost-effective solution for areas with available space. The choice between them requires careful consideration of technical requirements, economic factors, and site-specific conditions.